So for today's work, we're jumping right in. We're going to be solving equations that look like these. Now, first of all, notice what looks the same about these and what looks different about these compared to stuff we've done before. In these, we're solving stuff that has the x in the exponent. And so we've been solving stuff like that. So we already might have some idea. So let's jump in and start taking a look at how we might approach solving something that looks like this. First step, we always want to get the exponential by itself, right? Well, in this case, the exponential is the e to the power of x. Remember, e represents an actual number. It's not a variable. It actually represents a number here. So to get that by itself, I'm going to divide both sides by 2. And now I have e to the power of x equals 400. In order to solve e to the power of x equals 400, well, we're solving for an exponent. What do we always use to solve for an exponent? Log. Exactly. And so we change this into logarithmic form at this point. Now when we do that, we now have x equals log base e of 400. But I'll tell you, this is a bit of a pain. Because to do log base e, think about what the change of base formula would look like there. We'd have to do log of 400 over log of e. And your calculator has an e to the power of x button, but they don't all have an e button. Why would it only have e to the power of x and not e? There's actually a reason. Because there's a shorter way to write this log base e. There's an easier way to do it. A shortcut that we learned today. So, into your notes now. Please add this into your notes. What is a natural logarithm? Alright, so a couple little things to note here. First of all, yes, log base e is the exact same thing as writing it as ln. Now notice again, that is ln. That's not a 1n, that's ln. If you end up finding that difficult to always tell on your paper, sometimes it looks like 1n to you as you write it, well, using a cursive L is a great way to get around that. Then you can always tell that it's an L and not a 1. It's a nice way to keep track of it for yourself, something I often do, especially if I'm having to do a lot of work so I don't accidentally lose track of what's what. Alright, the other thing to note here is this is not the first time we've talked about ln, right? You've actually been using the ln button already. It's just you're always doing second ln because that's where the e to the power of x was. Now you know why e to the power of x is always connected to ln. Because ln has the e in it. So they're actually related functions, as we're going to see going forward here. So now that we've got this into our notes, we're going to go and use it again. So if I go back to that problem that I wrote earlier, I wrote it as x equals log base e of 400. Well, I don't even actually have to write that line. Once you get used to doing this particular switch, you're going to be able to go straight to this. X equals ln 400. Now, the first few you do at least, you're probably going to find it easiest to actually write the log base e and then turn log base e into ln. But after you've done some of them, and for everybody some means something different in this case. For some of you, you'll do just a couple and you'll feel comfortable going straight to ln. Others of you, you'll do a few dozen. And then you'll kind of get the pattern down and you'll be able to switch straight away there too. But just realize you don't technically have to write this line. You can go straight into this one. Alright, so then once I write it like this, now it's just a matter of doing the computation. So I'm going to figure out what is the natural log of 400. If you're doing it on a graphing calculator, you press the ln button first, then type in 400, press equals. On a scientific calculator, as you've seen with logs, you enter 400 and then you press the ln button. No second this time though, right? Because we're doing the actual natural log. We're not doing the e to the power of x. When you do that, you should get an answer here of about 5.99. And yes, that is a rounded answer. That's rounded to the nearest hundredth here. And with that one in mind, we're going to go on to the next one. And I'm going to make the next one that we talk about the one next to this. So we're next going to go to the ln x equals 5. Natural log of x equals 5. So have that one written down if you don't already. So in this case, we have natural log of x equals 5. It's like when we have a log of x. In fact, just like I was saying with that previous problem, we can often actually write it as log base e. when you're first learning how to use natural logs, that's a great step to do. Start by writing it as log base e of x. Now, technically we don't have to do that, but it connects the new concept of ln with the old concept of log. And so it makes the transition easier, because from here, I'm solving for the x. That means I'm going to need to change this into exponential form. When you solve an exponential, you turn it into a log. When you solve a log, you turn it into an exponential. And so what would this look like in exponential form? And so when we write this in exponential form, we know that we're going to end up with the base, which is e, to the power of whatever log equals, because log always equals the exponent. So it's going to be e to the power of 5, and then that will equal x. Now, I'm choosing to write it as x equals e to the 5th. If you wrote it as e to the 5th equals x, of course that is the same thing. It doesn't change the mathematics behind it. And again, if you wanted to, you could have gone straight from the ln x equals 5 to x equals e to the 5th. That's perfectly fine. Why would you put this in? Because it just makes it easier to look at, because you're used to doing it from that form. Now, you don't have to, and the more you do of these, eventually, yeah, you won't have to do that. But do it until it feels really comfortable doing it without it. All right, now we have x equals e to the 5th. I still need to solve it. Now, technically, this is the exact form, just like when you're doing like circles, like area of a circle, circumference, you leave pi in there when we ask for the exact form. This would be exact if it ever asked for exact. But of course, in this case, it doesn't, because it says up here round to the 100th. So we actually need to do that calculation. So you break out your calculator. You do the calculation just like we were doing the last couple days. We do e to the power of 5. You should get an answer of about 148.41. And having done those two, I think you got a pretty good idea about how to approach the last two as well. So go ahead and do the last two, or at least take each of them as far as you can. So if you run into a hiccup, at least take it until you hit that point. All right, so when doing that e to the power of 5x equals 500, we're solving for the exponent, so we want to change it into log form. Now, of course, we know from our previous work that I can write it like this. But what's a shorter way to write that? What's a shorter way to write log base e of 500? It's that ln 500. Because remember that log base e part of it. This is exactly the same as ln. And so that's what you want to write. Now, whether you include that other line as one of your steps is up to you. But you do need to get it to this point, because it's a whole lot easier to do this work by pressing the ln button than trying to figure out how do I type in log base e. That's the point of ln. It's making our lives easier, not harder here. All right, so going from there, you'll notice we have 5x equals here. I want to be a x equals. So I want to deal with something that I see some people saying, can I do this, can I not? Am I allowed at this point to say divide by 5, divide by 5, and so the whole thing is ln of 100? Am I allowed to do that? All right, and so the answer there is actually no. We cannot. Why? Because this 5 over here is just a whole number. It's sitting outside of the x. It's just a number. But this 500, it's actually trapped inside of the natural logarithm. If I wanted to put parentheses around it to make the natural logarithm function easier to notice, it'd be around that 500. That 500 is stuck inside of natural logarithm. And because it's not 500, it's natural log of 500, we can't just divide the 5 out. So we're actually going to have to save the 5 for last. So instead, the first thing I'm going to do is actually calculate what the natural log of 500. That gives us about 6.21. Keep the whole decimal on your calculator though, because then now that I have it just 5x equals a number, notice the 5 is a number, of course, but the 6.21 is just a number as well. It's not inside the log anymore. So now I can go ahead and divide both sides by the 5. When you do that, you should get an answer of about 1.24. And so taking a look at that problem's neighbor over here, am I going to be allowed at the start of this one to divide both sides by 7? Am I allowed to do 2 divided by 7 there? Well, the 7 is just a number. It's not inside any function. The 2 is just a number. It's not inside any function. So yes, we are allowed to do. And in fact, that's what we really have to do first, because if I'm going to solve a logarithmic function, I have to get the log part by itself. So now it's down to the natural log of x equals our decimal. Now, from here, we are going to have to change it into exponential form. We're going to have to do the same thing we did in the problem above it. Now, when doing this part, if you're feeling super comfortable, you might go ahead and go straight into this line. But I think most of you are still getting comfortable with this idea because you've only seen it come up a couple times now. And so if you want to start by writing this as log base e of x equals our decimal, that's a great way to help visualize how to then convert it into exponential form, because now it looks like what we're used to seeing. It's much more intuitive to switch into exponential form from there. If you haven't yet, do that and then calculate your answer. All right, and so when we change it into exponential form, this is what you're looking at. X equals e to the power of our decimal. Now, remember, the very first thing I did was I did 2 divided by 7. So this decimal that I just keep filling in here, that decimal is just still sitting on my calculator because I haven't done any other calculations. And so when I go to actually figure out what this equals, notice I still can use that exact decimal. On a graphing calculator, you're going to be pressing e to the power of, and then you would actually want to press that answer key. On your graphing calculators, that's the second negative, at least for most of your calculators. And so you do one of those if you're on a graphing calculator. If you're on a scientific calculator, of course, the order is different. On a scientific, with this number still showing on your screen, you would then just press the e to the power of button. And it would do it for you at that point. If you do it using the whole decimal to avoid rounding error, you should get an answer here of about 1.33. So the first thing you did is you wrote this down. We want to know all the critical information. And sometimes when we write these down, we do just kind of shorthand the information that's written up there. Ideally, yes, you'd have the whole thing written down verbatim. However, if you are shortening it, let's make sure that we see here in our original problem, what is it that really is essential that we have up here? We have a house that's currently valued at $200,000. Of course, any numbers are always going to be critical information in a math problem. You can decide later if it's unnecessary, but you always want to make sure to grab it at the start. If its value is increasing at an annual growth rate of 3%, compounded continuously, how much will it be worth in 25 years? Now you'll notice, there's 4 things that I underlined there, 4 important factors. 3 of them are numbers, nice and easy to find, but one of them isn't. And it's going to be a huge factor in how we do this problem. That's that compounded continuously. That's what tells us what equation we're going to have to use here. So make sure that you're always being aware of what type of equation is this. Compounded continuously is the very last equation that we got of our 3. It's the a of t equals p times e to the rt. Yeah, it's the one with e in it. Gee, I wonder why we're going to that one today, right? So we're going to go ahead and be filling into that equation here for this problem. So first of all, do we know what a is in this problem? Nope, because a, remember, is the final amount. We don't know what that is yet. We're going to try to figure out what the final amount is. So it's going to be a of t. Do we know what t is?
25.
Yeah, it's the 25. Okay, so we're going to go a of 25 equals p. P is principal. Do we know what the principal value is? That is the starting value. So yes, that's the 200,000. So we're going to go 200,000 e. Do we know what e is? Kind of messing with your head a little bit. It's e, right? Remember, e represents just a number. It's not a variable that we're plugging in for here. E represents e. R. Do we know what r is? Other than things that pirates say. We do know what is the actual value and this is where it's tricky, it's not 3. We have to turn the 3% into a decimal still. You don't have to add the 1 to it, but we do need to make it into a decimal. And so 3%, we divide that by 100, it gives us 0.03. And still up in the exponent, we're going to be multiplying that by t. We already know what t is. Remember, we filled that in back here. And so that's going to be 25. So we now have our equation. Now that we have our equation, this one's just a matter of figuring out what it equals. There's no fancy math to have to do here. It's just order of operations. So go ahead and calculate this value, please. Now, when doing this calculation, notice the first thing we need to do is we need to actually figure out what that exponent is going to equal. So we do the 0.03 times the 25. Then once we've done that, remember, I have to do the exponent before I do the multiplication. In other words, I have to do e to the power of 0.75 first. So you type in the 0.75 in your calculator, do e to the power of that. Then once you have that number, multiply it by the 200,000. If all has gone well, you should be getting an answer here of 423,400. Fairly pretty number, actually, surprisingly. This is going to be the last problem that we do together today. Now, of course, it looks very similar. All the information I've given to you here is basically the same. The house starts is worth $200,000. It's increasing at 3% per year, compounded continuously. The difference is we're going to be trying to figure out how many years will it take for it to be worth $600,000. So carry through a lot of the same information, but write down now what we've changed, and then we'll see how we address it and actually do it. All right, now again, it's compounded continuously, so I know I'm going to the PE to the RT equation. The one with E in it is used when it's continuously and only when continuously compounded. All right, now I want to start filling in. All right, just like last time, I'm just going to go through the equation and see what do I actually know. So, do I know what A is? A is our final amount. Yes, we do. We know where we want this value to end. We want to end up at 600,000. Do we know what T is? No, that's what we're being asked for. And so some of you, though, I know because of that, are writing this. This is a problem. We do not do that. Okay? The reason is because when I see A of t, it represents the amount at time t. It doesn't mean the value of A times the value of t. It means the value of A at some t. If I write this, that means 600,000 times t. I can't plug a number in for A and leave the t behind. Function notation doesn't work that way. I have to just put the 600,000 in for the whole A of t, because that's going to tell me my final amount at the unknown time, and then move on. Okay, P, I still know it. It didn't change. It's 200,000. E, R is the same thing. It didn't change. It's still 0.03. T, I still don't know it. And so it's going to be a T there. And so then this is my starting equation. Now we're going to solve it. We couldn't have solved this one before today, though. At least not without a major hassle on the calculator. But we do know from previous work what we do first, right? I got to get the exponential part by itself. The exponential part here is the e to the power of whatever. So I got to get rid of the 200,000, which means divide both sides by 200,000. What is 600,000 divided by 200,000? Yeah, that's nice mental math. That's just 3. Already, this thing's looking a whole lot simpler, right? 3 equals e to the power of 0.03t. Now, for some of you, it's kind of awkward seeing multiple things up in the exponent. But the process works the same as it would any other time. When I go to turn it into log form, log will equal the exponent, and so log will equal the same exponent. It'll equal the whole thing. I'm just going to say equals the 0.03 to the power of t. Now, when we write it in log form, go ahead and write it first the long way, because we're still getting used to the e being part of our logarithm. So we would start by writing it like this: 0.03t equals log base e of 3. But I'm not going to leave it that way. What does this become? Yep, that's going to become ln 3. That is the natural logarithm of 3. And now that we're at this point, go ahead and finish it out. Finish doing this calculation. Figure out what t is, please. All right, now as you're looking at this, remember I can't divide both sides by the 0.03 yet because it's 3 over here. It's trapped inside the logarithm. So I actually have to find that logarithm value. So you do natural log of 3 and we get that decimal. I'm just going to leave that on my calculator. I don't want to clear it off because I'm going to need it here in a moment. And so the last thing I need to do to figure out what t is I need to get rid of the 0.03 that's multiplied by it. So I'm going to divide both sides by the 0.03. And so again, with this decimal still sitting on your calculator, you just say divide by the 0.03. That way you don't run into rounding error by retyping in a rounded number, because you never round in the middle, or it will cause problems. And so we should end up with the final answer here. If we round out to the 100th place at least, it didn't specify, 36.62 is our rounded answer. If you round it out to the 10th, as often we do with years, then it would have been 36.6. Didn't specify, so I'm not picky on it.